Today, we're diving into VLSFO management and what it means for marine engineering officers. It's a topic that's become central since the IMO 2020 regulations, right?
Absolutely. With the sulfur cap in place, VLSFO, or Very Low Sulfur Fuel Oil, has really changed the way ships operate. It sounds simple, but the practical aspects are quite complex.
Yeah, I've heard a lot about compatibility and stability issues with VLSFO. Why are these fuels so finicky compared to the old heavy fuel oils?
The main issue is blending. VLSFO isn't just one type of fuel, it's often a mixture of different refinery streams. So, two VLSFOs from different suppliers can react badly if mixed.
That's like mixing two different salad dressings and ending up with a weird mess. So, what do marine engineers do to avoid this?
Testing is key. Before bunkering, officers usually request compatibility and stability tests. Sometimes they even keep new fuels in separate tanks until tests confirm they're safe to mix.
Makes sense. But with so many ports and suppliers, it must be a logistical headache. How do ships keep track of what's in each tank?
Detailed record keeping is essential. Most vessels use bunker delivery notes and maintain strict logs. It's like keeping a food diary, but for a ship's engine.
I like that comparison. But the consequences are a bit scarier than a dodgy lunch. What happens if incompatible VLSFOs get mixed accidentally?
You can get sludge formation, filter blockages, even engine damage. It can be disastrous mid-voyage. Think of it as your car stalling in the middle of nowhere, but with a few thousand containers on board.
That's a nightmare scenario. Does this mean marine engineers need to be chemical detectives now?
In a way, yes. They work with fuel analysis labs, interpret test reports, and make judgment calls based on experience. It's part science, part art.
Speaking of art, I've heard some officers joke that managing VLSFO is like cooking. You need the right ingredients, timing, and a bit of luck.
That's not far off. And just like in cooking, mistakes can ruin the whole dish, or in this case, the engine.
So, what about storage? Are there special requirements for storing VLSFO?
Definitely. VLSFO can be more sensitive to temperature changes and may stratify or separate in tanks. Ships often need to heat the fuel, but not too much, or you risk degradation.
Sounds like a careful balancing act. Do you think these challenges have made the job of marine engineering officers more stressful?
For sure. There's more paperwork, more monitoring, and a constant need to stay updated with new best practices, but it's also pushed the industry to modernize.
That's a silver lining. Are there any tools or technologies that help officers manage VLSFO better?
Yes. There are advanced fuel management systems now. They monitor tank temperatures, automate sampling, and even alert officers to potential issues.
Technology to the rescue. But I guess you still need a trained eye. Has training changed to keep up with these new fuels?
Training has become much more specialized. Officers now get regular courses on VLSFO handling, fuel testing, and troubleshooting.
Do you think there's enough sharing of real-life experiences among officers? That seems crucial.
Peer-to-peer learning is invaluable. Many shipping companies encourage officers to share incidents and lessons learned. It's like a story circle, only the tales are about bunker mishaps instead of campfires.
That's a vivid image. How about the environmental side? Does VLSFO actually deliver on the promise of cleaner shipping?
It does reduce sulfur emissions, which is great for air quality. But there's debate about other impacts, like higher black carbon emissions or differing energy efficiencies.
So, as with many environmental fixes, it's a trade-off.
Exactly. The industry is still adapting and research is ongoing. It's like trying to solve a Rubik's Cube, fix one side, and another side gets messed up.
I love that analogy. Do you think alternative fuels like LNG or biofuels will eventually replace VLSFO?
That's the big question. LNG is gaining ground, and biofuels are promising, but infrastructure and costs are still hurdles. VLSFO is likely to stay for a while.
So, marine engineering officers need to be multi-fuel experts now?
Pretty much. They're becoming fuel polymaths, juggling VLSFO, MGO, LNG, and whatever comes next.
It sounds both challenging and exciting. Are there any memorable stories you've heard from officers dealing with VLSFO?
Oh, plenty. One officer told me about discovering jelly-like sludge in the purifier. Turned out 2 incompatible VLSFOs had been mixed. They had to clean the system for hours.
That must have been a long night. It shows how high the stakes are.
Absolutely. But it also highlights the dedication and resourcefulness of marine engineers.
Is there any advice you'd give to officers who are still new to VLSFO management?
Never skip fuel testing, always check compatibility, and keep learning. And remember, if something feels off, investigate before it becomes a problem.
Wise words. What about collaboration with suppliers? Does that play a big role?
Yes, strong communication with fuel suppliers is crucial. Suppliers should provide clear specifications and support. It's a partnership, not a transaction.
That's a good point. So it's not just about what happens on board, but also about building trust along the supply chain.
Exactly. The more transparent the process, the fewer surprises down the line.
Let's talk about emergencies. If there's a sudden fuel quality issue at sea, what's the protocol?
First, switch to a safe tank if possible. Then, start troubleshooting, check filters, separators, and monitor engine performance. And, of course, inform the shore office and, if necessary, class society.
So, rapid response is key. Do officers run regular drills for these fuel emergencies?
Increasingly, yes. Drills now include scenarios like fuel contamination or loss of propulsion due to sludge. Preparation makes all the difference.
It sounds like being a marine engineering officer is a bit like being a firefighter, detective, and chemist rolled into one.
That's a fair description. And let's not forget, they still have to ensure the ship gets from A to B on time.
With all these challenges, do you think there's enough recognition for their role?
I think awareness is growing, especially as fuel management becomes more central to safe operations and environmental compliance.
That's encouraging. Looking ahead, what do you see as the next big challenge in VLSFO management?
Probably the integration of even more diverse fuels and adapting to stricter emission controls. Also, digitalization, using data to predict and prevent issues before they escalate.
So the future is more complex, but maybe also more predictable?
Hopefully. With better data, we can move from reactive to proactive management. That's the goal.
Before we wrap up, what do you think is the most important mindset for officers managing VLSFOs?
Stay curious, stay cautious, and never stop learning. The fuels may change, but the need for vigilance doesn't.
Great advice. Any final thoughts on the transition to VLSFO since IMO 220?
It's been a steep learning curve, but the industry has risen to the challenge. There's still work to do, but we're moving in the right direction.
It's inspiring to see such resilience and adaptability. Maybe in a few years, VLSFO management will be second nature and we'll be discussing the next big fuel.
Very likely. The only constant in shipping is change.
Thanks for this insightful discussion. For our listeners, what's one question they should think about after today's episode?
I'd ask, how can we balance safe and efficient VLSFO management with the push for greener fuels? It's a challenge for the whole industry.
That's a great point to end on. Thanks for joining us, and thank you to everyone listening. Stay curious, and see you next time.